What's up, guys? Mr. Maius here, and I am going to talk to you about increasing and decreasing functions, finding where the function is increasing and decreasing, and basically slope is positive, slope is negative, and using the first derivative to figure that out. So I've got right here the procedure that you're going to use to find, and yeah, I got these little green things. That's Word, of course, doesn't like the way that I thinks my grammar's messed up, but hey, it is what it is. Find the domain, find the critical numbers. This is similar to the candidate test, except now we're going to actually find where that slope is positive and where the slope is negative. So let's get to it here. I have this procedure on each of my pages here so that we can refer back to it each time. So the first step is we're going to see if there's any domain restrictions. Well, in this case, there are no domain restrictions, so we don't have to worry about step number one. Let's do step number two. Take the derivative. So f prime of x here is going to be 2/3 x squared minus 9 to the negative 1/3 times 2x. Don't forget your chain rule. All right, so that's going to give me 4x over 3 times x squared minus 9 to the 1/3 power. And I'm going to set that equal to 0. And I'm going to solve for x. That's going to give me x equals 0. And then I also know that x cannot be plus or minus 3. These are all my critical numbers. All right? Because they're critical numbers because it's not differentiable at plus or minus 3 because I'm in the denominator here, and x equals 0 will actually give me a critical value. So now what I'm going to do is I'm going to go on to step 3. I'm going to locate these critical values on a number line. So I'm going to draw my number line, and I'm going to write -3, 0, +3. All right. This is going to be an open circle. And what I'm going to do here is I'm going to decide whether or not the derivative is going to be positive or negative in each of these intervals. So I'm just going to pick a number like -4, -1, 1, and 4. These are numbers that are in those intervals. I'm going to plug that number in here in my derivative and determine if it's positive or negative. Now, I wouldn't actually recommend trying to figure out what that is. You just got to kind of think about what's going to happen, all right? If I put a -4 in here, I'm going to get a -16, right? So that's going to give me a negative on top. And then if I plug -4 in here, it's going to give me a +16. That's going to give me 16 minus 9, which is a positive number, giving me the entire bottom to be positive. And a negative divided by a positive is a negative. So I want to check this, and I'm going to write negative here to denote that in this interval, my derivative is negative. Then I'm going to plug in -1. I'm going to try that. I'm going to get a negative divided by a negative, and that's going to give me a positive. I'm going to plug in +1. And that's going to give me, when all is said and done, a negative. And I'm going to plug in a +4, and +4 is going to give me a positive. So in general, my graph is going to decrease, then it's going to increase, then it's going to decrease again, then it's going to increase again, like a big W. Big W. All right, so what does that tell us? That tells us here we have a relative min. Here we have a relative min. In fact, one of these might be an absolute. We'll just label it as relative for now. And this is going to be a relative max. All right, well, we should probably figure out where those are. It says find the intervals, so we can see these intervals on which these functions are increasing and decreasing, and find all local extrema points. So we actually want to find these points, okay? So the first thing we're going to do, let's label where these are increasing and decreasing. So the way we're going to do that is we're going to write f increases on the interval -infinity to negative, oops. Let me erase that. It increases on the interval -3 to 0, right? It goes up. And the interval 3 to infinity, since f prime is greater than 0. So we have to actually write out that we understand that f prime is positive there. Okay, then we're going to write f decreases on the interval negative infinity to negative 3 and 0 to 3 since f prime is less than 0. Okay, that's how we justify. This right here is our justification. And it's normally on the AP exam, they're going to ask you, justify. So this is how we justify it. All right, now if we want to find the values of our relative min and relative max, we're going to go and plug in these values. Now, we're going to plug in negative 3 in for our original function. All right, and then we're going to plug in positive 3 for our original function. We're going to plug in 0 for our original function. So when we do that, I believe we're going to get 0 and I think I get negative 9 to the 2/3. That's going to be our relative max. And then we have our relative mins here, and we're going to plug in 3 in there. And that's going to give us, let's see, 3 squared minus sine is 0. So this is going to give us negative 3 comma 0 and 3 comma 0. All right, so it gives us our points where we have our local mix and max and mins extrema. Let's do another one. So this time I have y equals x minus 2 sine x. So I'm going to look for the domain restrictions. No domain restrictions. So I'm going to take the derivative. 1 minus 2 cosine x. Set that equal to 0. Solve for x. And I get x equals pi over 3 and 5 pi over 3. All right, so then what do I do here? Well, I do the next step. I make my number line. So number line, and I'm going to go from 0 to pi over 3 to 5 pi over 3 to 2 pi. And the only reason I'm doing it like this is because I'm restricted right here on my interval. Okay, so I got zeros here, okay, and I want to check, a good number to check in here is pi over 2. So I check pi over 2 in here, and I get that this is going to be positive. Right, because cosine is going to be a 0. Then here I'm going to get negative and negative when I plug in my values in here to check whether the derivative is positive or negative. So this is going to be going down, up, down, down, up, down. So I have a relative min right there and a relative max right there. Let's go ahead and plug those values in. I'm going to plug in pi over 3 in my original function. So I'm going to get pi over 3 minus 2 times the sine of pi over 3, and that's going to give me pi over 3 minus root 3 when I all said and done. And then my relative max is going to be at 5 pi over 3, and when I plug that one in, I'm going to get 5 pi over 3 plus root 3. So these are my points. Let's go ahead and write down our justification. So y, I like f, but let's write the function. The function, colon, increases on the interval from pi over 3 to 5 pi over 3 since, remember, we got to justify f prime is greater than 0. And it decreases on the interval from 0 to pi over 3 and 5 pi over 3 to 2 pi since f prime is less than 0. Don't forget to justify. Justify. All right? Now, one more thing we want to justify. Why is this a relative min? Because f prime changes from negative to positive. And over here, the relative max, because f prime changes from positive to negative. Okay, So we have to write here somewhere why we know it's a relative min, why we know they increase, and why we know they decrease. I think I have some time. We can do a couple more here, and so let's go on to the next one here. We've got f of x equals, hopefully you can see that, f of x equals x to the fourth, whoa, what's that, plus 3, there's a little snake going there, over 3x. So we're going to go and do our, first of all, our domain is x cannot be equal to 0, right? Because we have it in the denominator. So this is going to actually be a critical number. So we'll go and put that on our chart when we get to it. So we're going to take our derivative, and we're going to low-y high this guy. All right? Okay, so we're going to go low-y high minus high-y low, square the bottom, and away we, square the bottom, and away we go. All right, so I'm going to simplify that a little bit. 9x to the fourth minus 9 over 9x squared. So we're going to set that equal to 0, and that's going to come out to be x. We're going to take 9x to the fourth minus 9 equal to 0. Factor out our 9, and we get x equals plus or minus 1. All right, so let's go ahead and put our critical values here on our number line. We've got -1, 0, and 1. Now something I like to do is put a little dash here. What does that dash mean? Vertical asymptote. So that helps me just know that there's going to be a vertical asymptote there. So let's go ahead and pick values. We want values to pick -2, -1/2, 1/2, and maybe 2 here. And when we plug those guys in, remember we're plugging these in into our derivative. It's pretty easy to figure out what's going to go on here because we put a -2 in here and we've got squares, so these are going to stay positive, and this is going to be bigger than that one here. So in this case, so we're going to have positive. This -1/2 though does make this bottom here smaller, so we're going to actually have a negative right here. And same thing here. This is going to be a smaller value than that 9. So it's going to make this negative, and then this one's going to be positive because it's just going to be a bigger, way bigger value than that. So in general, so this is our f prime of graph, and in our general, our f graph is going to go up, then down, increase, then decrease again, and then increase. And we're probably going to go up towards a vertical asymptote, down towards a vertical asymptote here. So how are we going to write this up? All right, so here we have right at this spot here, we're going to have a relative max at, what's this point? -1. And if I plug -1 back in here, I'm going to end up with -4/3 because f prime changes from positive to negative. And right here, I'm going to have a relative min at the point 1, comma. When I plug in the 1, I'm going to get 4/3 because f prime changes from negative to positive. All right? So then we're going to do our increasing and decreasing. So f increases from -infinity to -1. And we've got increases from 1 to infinity. Get this guy out of the way. Since f prime is greater than 0. And it decreases from -1 to 0 and 0 to 1 since f prime is less than 0. All right. So there we go. We've got 3 examples here, and I will do, I'm running out of time. I only have 15 minutes on this video, so I got to cut it right here, and then I'll have one more video, one more example of using increasing, decreasing, and the first derivative test. Later, guys. See you soon.